Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 65 from the Smith Organic Chemistry textbook. In this problem, we're asked to synthesize these 8 compounds, starting from cyclohexanol, and then using basically anything else that we need to. Okay, so this is going to be a long problem. I'm just going to jump into it. So for A, I would start by using PBr3 to go from cyclohexanol to the bromide. Then treat that bromide with magnesium to get the Grignard. And then that Grignard, we could use formaldehyde and then work the reaction up with some water. And that's going to give us our desired product here. Okay, so that's A. That's a good route for A. So looking at B, we can start from the Grignard that we made in A. And for most of these, I'm going to reuse things that I made in earlier parts of the problem. So if I don't show where something comes from, understand that it came from earlier in the problem. So in this case, we made this just above this in A, the cyclohexane magnesium bromide. And so instead of using formaldehyde, if we use carbon dioxide here, and then again, a water workup as always, or actually, I apologize, with carbon dioxide, we should do an acidic workup. So H3O plus. And so that is going to get us the carboxylic acid here, which is what we were looking for. Okay, so that's B. Try to fit C in here. So for C, I'm going to start from cyclohexanol once again. And I'm going to do an oxidation. So chromium trioxide. So chromium trioxide and then water and sulfuric acid would work. But PCC will work equally well, and it's a safer reagent and easier to use. So let's use some PCC. So that's going to get us to our ketone. We can then use a methyl Grignard. With water workup. That is going to get us here. So a methyl group here, alcohol here. So now we can treat this with some consulfuric acid. So H2SO4. That's going to give us an elimination. So we'll get elimination there, double bond, and we can then epoxidize that double bond with some MCPBA, and that is going to get us to our product for part C. So there we go. There's the product for C. So moving on to the next page here, let's take a look at D. For D, okay. So again, for D, I'm going to start from cyclohexanol. And the first thing I'm going to do here is going to be an elimination. I'm going to eliminate the alcohol. So H2SO4, consulfuric acid, give us the alkene. We can then epoxidize that alkene with MCPBA once again. So we have our epoxide, and we need to add a phenyl ring. And so we can use phenyl magnesium bromide, phenyl Grignard reagent, so pH MgBr, followed by a water workup. As always, is going to give us this. So we'll have our alcohol here, and we'll have our phenyl ring added there. And then the last thing that we need to do is just oxidize this alcohol up to a ketone. And so PCC is good for that. And that gets us to our final product for D. Okay, so moving on to part E. Okay, let me see. Okay, so what I'm going to do for part E, I'm going to start from the ketone that we made in part C. So we made this ketone, and then to add the alkyl chain that we need, the easiest way to do that is going to be to use a Grignard. It's a 3-carbon chain, so we'll use propyl Grignard reagent. 1, 2, 3. Followed, of course, by water workup. So now we'll have an alcohol here, as well as our propyl chain. And so we need to get rid of this alcohol. And so what we can do is use some consulfuric acid, do an elimination. Once we do this elimination, we'll have an alkene, and then we can get rid of the alkene just by hydrogenating. So H2 PDC. That is going to get us to our final product here. All right. So taking a look at part F now. So part F, the product that we're looking for is not a ring. There's no ring in it. And so what I do see is that there are 2 carbonyls in it. So I'm going to say that we're going to use ozonalysis to cut this ring. So again, I'll start from the ketone that we made in part C. So the same starting material that we used in part E, just above this. So we'll start from this ketone. We will add the methyl group that we need. So making use of a Grignard once again. Okay. So now to get the alkene that we can then ozonolize, we'll use consulfuric acid to do an elimination. And then we can ozonolize this molecule So that's going to be ozone and then dimethyl sulfide. And that is going to get us to our final product here. Okay, so there we go. Moving on to the third and hopefully final page. So for part G, okay. So for part G, we're going to use two different things that we made in part A. So we will start with this. We made this in part A, and we'll oxidize this molecule, PCC. Okay, so we have this aldehyde now. Also in part A, we made this Grignard reagent. And so we're going to use that again, followed, of course, by water workup. And that's going to get us to the carbon skeleton of what we need. But we have the alcohol here. And so one more PCC oxidation is going to get us to our final product with the oxygen in the correct oxidation state, the ketone. All right. So that's part G. And lastly, part H, we'll again start from this ketone that we made in part C. It's been a popular starting material in this problem. So here's that ketone once again. We'll use this cyclohexane magnesium bromide reagent that we made in A. Water workup. That's going to give us this. So we'll have the alcohol here, and then we'll have another ring here. Okay. And then if we do an elimination with concentrated sulfuric acid, we'll probably get a little bit of side product as well. But the main product that we'll get will be this desired product. Okay. Yeah, and so that'll be the major product there. Yeah, and so there's no way to do this other than just knowing all of these reagents and what they do, and being able to look at a product and think about how can you get from where you're starting to that final product that you need. And that's the answer to chapter 20, problem number 65.